This is a graph produced by one of our classes for the Comparing Volume Units activity. Remember, the purpose of this activity was to compare centimeters cubed and milliliters. So when we did this, we took different objects of different sizes and we measured their volume with a ruler and calculated the volume of the cylinders, and the units on that would be centimeters cubed. And then we also found the volume via water displacement using a graduated cylinder, and that would be the volume in milliliters. So when we graphed that, we graphed it so that centimeters cubed were on the y-axis and milliliters were on the x-axis. When we plotted the whole class's data, we got what looked to be a relatively linear plot. From that, we added a trend line and found the equation of our line. The equation of our line is y equals 1.0469x minus 0.1184. So we're going to use that equation of our line to analyze some of our data. So the first thing that I want to look at is our slope. Now, when we calculate slope normally in math class, we're looking at rise over run or y over x. So our slope is 1.0469. Since we're in math class, we need units with that. Our units for our y-axis were centimeters cubed, and our x-axis was milliliters. That means this slope has units of centimeters cubed over milliliters. So this slope tells us for every 1 milliliter, we have 1.0469 centimeters cubed. Now you're probably thinking to yourself, that's really close to 1. And if we were perfect, if we measured everything perfectly, our slope would have been 1. We should have had a slope of 1 centimeter cubed over milliliters. Oops, it's not very good cubed. Which means that 1 centimeter cubed is equal to 1 milliliter. They measure the same amount of volume. So if I have 2.5 centimeters cubed, that means I also have 2.5 milliliters. If I measure something to be 10 milliliters, that means it also has a volume of 10 centimeters cubed. They measure the same quantity. Now the next piece that I want to look at is the Y-intercept. Our Y-intercept for this graph was 0.1184. Now if we think logically about this, our Y-intercept should have been 0. We should have started at 0, 0. We should have started at the origin, because if we think about it, if we are measuring no volume, it doesn't matter what units we're using. 0 centimeters cubed is going to be 0 milliliters. Since it didn't start at the origin, since our y-intercept isn't 0, that tells us we have some amount of error involved. So we can see that we have errors because our y-intercept isn't exactly what it's supposed to be, and our slope isn't exactly what it's supposed to be. So let's talk about some of the errors involved in this lab. So 2 of the main errors are measurement errors, or measurement estimations. Everyone's a little bit different when they estimate values, and we had to estimate when we were using our ruler, and we had to estimate when we were using our graduated cylinder. So estimation values could cause differences. We also have just issues measuring a cylinder. When we measured the cylinder, we had to measure the diameter, and we don't know exactly where the widest part is of that circle, of the end of the cylinder. So there's an estimation involved in that as well. Since we were doing calculations, there's always the possibility for calculation error. And then finally, when we're doing volume by displacement, there's always the possibility that some of the water splashed when we dropped the cylinder into the graduated cylinder. So we have a water splashing possibility. If that water splashed up and out of the graduated cylinder, you're no longer measuring it. Even if it splashed up into the top space of the graduated cylinder and clung to the side, you're still not measuring it. So it's going to alter your measurement value. Now the whole point of this was to look at centimeters cubed and milliliters, and we've learned a couple different things. Both centimeters cubed and milliliters measure volume. However, centimeters cubed are typically used when we're measuring solid objects, things that we can measure with a ruler. We use milliliters when we're measuring liquids, when we have to use a graduated cylinder. But centimeters cubed and milliliters are equal to each other. So if you measure something in milliliters, you also know its volume in centimeters cubed. We also practiced how to analyze the equation of a line. So we used the slope to determine the relationship between two of our variables. And we used both our slope and our y-intercept to determine where there were errors in our procedure. And then finally, we went a step beyond just saying there's general human error, and we analyzed what we did to determine what some of our specific errors were when we were doing this procedure.